Factoring by grouping. It's important to remember that factoring a polynomial is the opposite of expanding. And example 1. So we're going to look over here at example 1. This is expanding a polynomial. And remember, we use FOIL here. Firsts, outers, inners, lasts. Firsts, 2x times negative x is negative 2x squared. Outers, 2x times 4 is plus 8x. Inners, negative 3 times negative x is positive 3x. Lasts, negative 3 times positive 4 is negative 12. And now we can combine our x terms there, and that's going to be negative 2x squared plus 11x minus 12. So, there are different methods for factoring. In this method, we break the polynomial into parts and factor out the greatest common factor. The GCF is the greatest common factor. And the greatest common factor goes all the way back to 4th grade. So, from the parts, example 2. So, yeah, you can do this with just numbers, but you can also do it with polynomials. So, I'm going to factor out the greatest common factor there. And I'm also going to factor out the greatest common factor there. So if we look at just the blue part, we can see that 2 and 6 have a common factor of 2, and then x squared and x have a common factor of x. So the greatest common factor there is going to be 2x multiplied by the quantity x minus 3. Now notice that when we do 2x times x, we get 2x squared. And when we do 2x times negative 3, we get negative 6x. So distributing there is the opposite of factoring. And in the next part, the positive 3x, so the positive 3 and negative 9 have a common factor of 3. And there's nothing else with a common factor. So we have a 3 that we're factoring out, and so 3 times x is 3x, and 3 times negative 3 is negative 9. So far we've factored out the things that we need to factor out there. Now, yeah, so the thing that you really need to see here is super important, is that whatever we have, the part of the factors of each, is the same. And so what we're saying is this whole thing has a factor of x minus 3, and this whole thing also has a factor of x minus 3. And so for that reason, we can factor out the x minus 3. So we have, let me see, I'm going to use green here. So I'm going to now take this and that's going to be the quantity x minus 3. And then from the other part, we have the quantity 2x plus 3. So that is the way that we can factor there. One way to check your work is to expand the result of your answer, and we're going to look at example 3. Now notice that in example 3 we have the quantity x minus 3 second, but in our example 2 it came first. Doesn't matter either way, it comes out the same. So if we're going to FOIL here, 2x times x is 2x squared. Firsts, outers, 2x times negative 3 is negative 6x. Inners, 3 times x is positive 3x. And last, positive 3 times negative 3 is negative 9. We can combine our x terms. so that we get 2x squared minus 3x, was going too fast, minus 9. So now notice, oh, you know what? I went too far, but really the key here is that that is the same. Now, it could turn out that we had 2x squared plus 3x minus 6x minus 9, and that's the same as well. So either way, it doesn't matter. All right, sometimes factoring out a greatest common factor from every term makes factoring easier. So we're going to look at an example where that's true, here in example 4. So each of these terms has a factor of 5, and that's the greatest common factor. So we're going to factor out that 5. So when we factor out 5 of 30x cubed, we get 6x cubed minus minus 4x squared minus 3x and plus 2. Now we're going to continue to factor on just this part. So we still have the 5 out front, and what we can factor out of this is a 2x squared. So 2x squared, and we're multiplying that. So when we factor 2x squared out of 6x cubed, we get 3x. And when we factor 2x squared out of negative 4x squared, it's negative 2x, or negative 2, excuse me, that's all. And here, well, that actually looks exactly the same as this, except all of the signs are changed. So we're going to factor out a negative 1 here. And when we factor a negative 1 out of negative 3x, it's a positive. Whoops. I need to... So that's going to be minus. I need to put in a set of parentheses here around the whole thing because we're multiplying all of this by 5. So we need a set of parentheses there. So we're going to factor out a negative 1. And when we factor, I'll get this straight. When we factor a negative 1 out of negative 3x, so that's a negative 1, we get a positive 3x. And when we factor negative 1 out of positive 2, we get negative 2. And now we can see that we have that 3x minus 2 is the same. So we have the 5 out front, and then we have the 3x minus 2 times the quantity, so that's the 3x minus 2, times the quantity 2x squared minus 1. 2x squared minus 1. And that is a pretty tough problem, especially when we're really only looking at our second example of factoring. That's pretty tough. So there are 4 steps we can follow when we use this method for factoring. And really the first step might be not always necessary, but factor out the greatest common factor. Factor the GCF, the greatest common factor. And so what I'm talking about there was, like in this one, we factored out that 5. That was the first step. And then number 2, we split the middle term. In this case, we didn't have to split the middle term, but later we'll see that if the middle term isn't split, we have to do that. Split the middle term. Step 3, factor by grouping. And step 4, check your work. And we didn't check our work there, but remember, you can always do that by expanding. So this method can also be used on trinomials, but an extra step is required, and I actually included it there. It's the split the middle term. And we should only use this method when the discriminant is positive, which means that there are two real solutions. We need to split the middle term, and that's what I said above. That's the x term. So the term that has the x, not or n or p, so not a variable squared and not a constant. It needs to be split in a special way. The product of the split must be equal to the product of A. So the product of the split must be equal to the product of A and C. So when we multiply A, the leading coefficient, by C, the constant, however we split the middle term has to be split so that the two coefficients equal A times C. And I'll show you that in just a minute. And the sum of the split must be equal to B, and that's the coefficient in front of the variable. So we're going to look at this a few times. So what we can see here is the middle term needs to be split, and we need to split it so that when we multiply the two coefficients, that they equal 2 times negative 2, which is negative 4. And that comes from 2 times negative 2 equals negative 4. So however we split this, it needs to be split so that the coefficients equal negative 4. So we have 2n squared, and they have to add to negative 3n. So if I have negative 4n plus 1n, notice that this does equal negative 3n, and negative 4 plus 1 is, or multiplied by 1, negative 4 times 1 is negative 4. So that's the two things we have to have. Negative 4 times plus 1 is negative 3, and negative 4 times 1 is negative 4, minus 2. So that's, there was no greatest common factor for all of our terms, so there was no step 1 to do there. Step 2 is split the middle term. Step 3 is factor by grouping. So when I look at this part, I can factor out a 2n. 2n squared divided by 2n is n. And negative 4n divided by 2n is negative 2. So maybe I'll make that clear. 2n squared divided by 2n is n. Negative 4n divided by 2n is negative 2. So now we're going to focus on this part. And sorry about that. Look here, this is exactly the same as that. So it's just going to be plus 1 times the quantity n minus 2. And you actually don't have to have that 1 there, but it's pretty useful when you're looking at it this way, because now you can see that what we have is 2n plus 1 times the quantity n minus 2. And that's done. And this video is going pretty long. Good on you for sticking with me if you have. Now these three terms are all divisible by 6. So the first thing I'm going to do here is I'm going to factor out a 6. So we have then k squared. Oh, they are not divisible by 6 because 16 is not divisible by 6. What am I talking about? But they are all divisible by 2. So 2. So 6k squared divided by 2 is 3k squared. 16k divided by 2 is 8k. And 8 divided by 2 is 4. So now we really are focusing on this part. So we have 2 times, and I'm going to use the square brackets so that I can keep track of where everything needs to be. Now I need to split apart my 8k. And however I split it, 3 times 4, so that's 3 times 4 is equal to 12. However I split it, the product needs to equal 12. So how am I going to split 8 so that the product equals 12? 8 times 1 doesn't work. 4 times 2 doesn't work. Oh. Or no, 4 times 4. 6 times 2. 6 times 2 works. 6, yeah. It would be 8 times 0. I confused that up pretty bad. So I have a, whoops, sorry about that. I have 3, wow, my iPad's jumping all over the place. 3k squared plus 6k plus 2k plus 4. And so now I've split it apart. Now I can factor the greatest common factor out of the 2 parts. So here I have, I can factor out a 3k. So 3k times, well, 3k squared divided by 3k is k. 6k divided by 3k is 2. Now I'm looking at this part, and I can divide out a 2. So I have plus 2 times the quantity. 2k divided by 2 is k. And 4 divided by 2 is 2. All right, now I can factor out the k plus 2 from these 2 parts. So I have 2 times the quantity. That's really sloppy looking work there. 2 times the quantity. 3k plus 2, so that's the 3k plus 2 in parentheses, times the quantity k, whoops, k plus 2. And if I were going to check my work on these, I would use expanding. All right, last one here. There is no greatest common factor here. So the first step is to break apart my middle term. And remember, the way that I want to break it apart is so that when I multiply the 2 parts, it has to equal 20. So however I break this apart, it has to add to 21 and multiply to 20. Well, multiply to 20. 20 times 1? No. Oh, wait. Yeah. 20 and 1 will work. So plus 20p plus 1p. So notice that 20 plus 1 is 21. And 20 times 1 is 20. And now we have the plus 4. Now, these parts, I can factor out 5p multiplied by p plus 4, because 5p squared divided by 5p is p. 20p divided by 5p is 4. And now here, this is 1p plus 4, p plus 4, same thing. So I'm just going to have plus 1 times the quantity p plus 4. Now, 5p plus 1 times the quantity p plus 4. And I hope that this helps. This is not easy stuff, folks. Good job sticking it out with this super long video. If you have questions, please do ask during class.